Hey there everyone, Ramesh here, back again with another course titled Build REST API with Spring Boot 3. Well, this is going to be a 3-hour full course. In this course, I want to show you how to build the REST APIs using Spring Boot 3 line by line coding in IntelliJ IDEA. As we know that Spring Boot is very popular Java framework for building RESTful web services, and at the end of this course, I am pretty sure that you will learn building REST APIs with Spring Boot 3. Well, in this course, we are going to build the REST APIs for two important projects, employee management system project and banking application. So we are going to use the real-time databases like MySQL database and PostgreSQL database in this course. Well, we'll begin with building Hello World REST API, and gradually we'll start building the REST APIs for employee management system project and banking application. Basically, we'll learn the REST APIs step by step. Alright, without further ado, let's go and let's create a Spring Boot project and let us start building REST APIs. Hi everyone, welcome back. In this lecture, we'll create and set up Spring Boot project in IntelliJ IDEA. Well, first, we'll create a Spring Boot project using Spring Initializer, and then we'll import that project in IntelliJ IDEA. Well, let's head over to the browser. In a new tab, just type start.spring.io. This will bring up Spring Initializer. Well, Spring Initializer is a website or a web tool that we can use to quickly create and bootstrap Spring based applications. Now let's go and let's fill up the project information over here. Well, here we have two types of project, Maven project and Gradle project. We are going to use Maven project, so let's keep Maven project as selected over here. And here we have three kinds of JVM languages, Java, Kotlin, Groovy. We are going to use Java, so let's keep Java as selected over here. Next we are going to use Spring Boot version 3, so let's select Spring Boot 3.0.0 milestone 4. So this is the latest version of Spring Boot as of now. Next, let's fill up the project metadata over here. So let's give group as net.javaguides. Well, you can give any group that you want. Next, artifact. Let's give artifact as Spring Boot REST API. Next, let's give project name as Spring Boot REST API, and then description demo project for Spring Boot REST API, and then packaging name as net.javaguides.spring boot, and then packaging as a jar, and then Java version 17. Well, remember, whenever you choose Spring Boot version 3, then you have to choose Java version 17 or later. Next, let's go ahead and let's select the dependencies. We'll go ahead and click on add dependencies over here, and here just type web. Well, Spring Boot provides Spring Boot starter web dependency that we can use to develop the RESTful web services, and this dependency internally provides Apache Tomcat as a default embedded container so that we can able to run our Spring Boot application in a development environment. Alright, so let's go and let's select Spring Web Starter dependency. Well, as of now, let's keep this single Spring Web Starter dependency. If any dependency is required, we will add in our upcoming lectures. Next, let's go ahead and let's click on generate button to generate this Spring Boot project as a zip file on local machine, and you can able to see here our Spring Boot application is downloaded as a zip file over here. Next, let's go and let's open in a folder and let's unzip this folder. Alright, now we have Spring Boot REST API project in place. Next, we are going to import this project in IntelliJ IDEA. Let's open IntelliJ IDEA, and in IntelliJ IDEA you can see a couple of options: new project, open, get from VCS. Well, we are going to open the existing project in IntelliJ IDEA. For that, let's go and let's click on this open option over here and go to the location where your Spring Boot application is present. In my case, it is in downloads folder. So go ahead and select the project and click on open. Now this will open Spring Boot project in IntelliJ IDEA. Alright, perfect. Next, if you can see the SRC folder, within that we have main folder, and within the main folder we have Java and resources. Within a Java folder we keep all the development related source code, and within a resource folder we keep all the static resources as well as UI related resources and all the application level configuration in a application.properties file. And here we have test folder, within that we keep all the JUnit test cases. Next, we have pom.xml file. It contains all the Maven dependencies and Maven plugins. Now let's go ahead and let's explore more about this Spring Boot starter web dependency. Well, Spring Boot provides Spring Boot starter web dependency to develop the RESTful web services as well as Spring MUC web applications. And this Spring Boot starter web dependency, it internally provides all the required dependencies to develop the RESTful web services. Along with that, this dependency also provides Apache Tomcat as a embedded default container. For example, if we dive into this dependency internally provides Spring Boot starter JSON dependency, Spring Boot starter Tomcat dependency. Okay, apart from that, it will provide all the Spring related dependencies like Spring Web dependency, Spring Web MUC dependency. It means that this single dependency will gather all the required dependencies to develop the Spring MUC RESTful web services. Along with that, it will also provide a default embedded Tomcat server. Okay, we don't have to configure the external Tomcat server to deploy our Spring Boot application. This dependency internally provide embedded Tomcat server so that we can quickly deploy our Spring Boot application in our local development environment. Alright, great. Now let's go and let's quickly run our Spring Boot application and let's see how it works. So go to the main entry point class. So this is basically our Spring Boot main entry point class. It has a main method. Alright, so typically in Java programs we have a main method and the execution of the Java program starts from main method, right? So similarly in Spring Boot we have a main method and the execution of the Spring Boot application starts from here. Okay, so we can simply use this main method to start our Spring Boot application. So go ahead and run the Spring Boot application by using this entry point class. And notice here in a console our Spring Boot application is up and running in an embedded Tomcat server on port 8080. Well, let me recap what we have done in this lecture. We have created and set up Spring Boot project in IntelliJ IDEA, and we quickly gone through the project structure and we have explored about Spring Boot starter web dependency, and we ran our Spring Boot application, and our Spring Boot application is successfully running in a embedded Tomcat server on port 8080. In upcoming lectures we are going to develop the RESTful web services. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture we will create a simple Spring Boot Hello World REST API. Well, creating REST APIs using Spring Boot is very simple. Alright, so let's head over to the IntelliJ IDEA and let's quickly create a simple Spring Boot REST API. Well, go to the main package over here, and within that let's quickly create one more package and let's call it as controller. Well, within a controller package we keep all the Spring MUC controllers. Now let's go ahead and let's create a Spring MUC controller. Well, right click on the controller package, new, and then choose Java class, and let's give class name as a Hello World Controller. Well, notice here the naming convention for this Java class, Hello World Controller. Well, whenever we create a Spring MUC controller, we always use controller as a suffix for this class name. And here Hello World is nothing but a resource followed by controller is a suffix for this resource. Okay, so this is the Hello World controller. Some of the developers also use other naming convention like Hello World resource, but in typical Spring MUC projects we use the naming convention like Hello World controller. Okay, we always use controller string as a suffix for a controller name. Okay, now we have Hello World controller. Go ahead and hit enter. Now we have created a Java class. Let's make this Java class as a Spring MUC controller by using @controller annotation. Well, let's go ahead and let's annotate this class with @controller annotation. And notice here @controller annotation is a stereotype annotation from org.springframework.stereotype package. So let's go ahead and let's select this annotation over here. Well, whenever we develop the RESTful web services using Spring MUC, all the REST APIs return a JSON to the client, right? So in order to convert a Java object into JSON, we have to use @response_body annotation. So let me go ahead and let me use @response_body annotation over here. Well, whenever we develop the RESTful web services using Spring MUC, we always use these two annotations, isn't it? We use @controller annotation to make this controller class as a Spring MUC controller, and we use @response_body annotation to convert a response from Java object to JSON, and that JSON will be again written into HTTP response. Well, as we know that whenever we develop the RESTful web services using Spring MUC, we have to create a controller class and we have to annotate this controller class with these two annotations, isn't it? Spring team thought like, why not we create a shortcut single annotation? It internally uses these two annotations, right? So Spring team released @REST controller annotation. It internally uses these two annotations. For example, let me remove these two annotations, and here let me use @REST controller annotation over here. Well, Spring 4.0 released this @REST controller annotation, and this annotation is a combination of @controller and @response_body annotation. For example, If we dive into the source code of this at REST controller annotation, here you can able to see this annotation is annotated with at controller annotation as well as at response body annotation. Okay, so at REST controller annotation is nothing but it is a combination of controller and response body annotation. Well, instead of using these two annotations, we can use the shortcut single annotation, that is at REST controller annotation. Alright, perfect. Let's go back to hello world controller. Now we have annotated our hello world controller class with the at REST controller annotation. Okay, just remember, whenever you want to develop RESTful web services using Spring MVC, you have to annotate a class with the at REST controller annotation. Now this class becomes a Spring MVC REST controller. Within this REST controller, we can create the REST APIs. Now within a hello world controller, let's go ahead and let's create the REST API. So creating a REST API is pretty simple. We just have to create a method and we use Spring annotations to make that method as a REST API. Okay, perfect. So here just type the method public and let's give return type of the method as a string and let's give method name as hello world. Perfect. And let's return some string, something like hello world. Now we have created simple Java method. Let's make this Java method as a REST API using Spring annotation. Well, this is going to be a HTTP GET request. Right, so let's go ahead and let's use at GET mapping annotation to handle HTTP GET request. Well, basically we use at GET mapping annotation to map incoming HTTP GET request to this method. Okay, and next let's go and let's configure the URL for this REST API. So here let's pass the URI something like hello -world. Perfect. So whenever a client want to access this REST API, then client have to use this URL. For example, http://localhost:8080/hello world. Perfect. So whenever a client want to access this REST API, then client have to use this URL. Alright, perfect. So let me copy this URL. Now let's go ahead and let's run the Spring Boot application and let's see how this REST API works. So let me stop the existing server and let me start the Spring Boot application again. And look at here, our Spring Boot application is up and running in an embedded Tomcat server on port 8080. Well, this is the GET REST API, so we can access this REST API using browser. So let's go to a browser. In a new tab, just paste this URL, that is http://localhost:8080/hello world and hit enter, and there we go. You can able to see the client got a response from the REST API. And if you can see the REST API, this REST API returns hello world string, isn't it? And you can see in the browser, the client got hello world in a response. It means that we have successfully developed Spring Boot Hello World REST API and it is working as expected. Well, creating the REST APIs using Spring Boot is very simple. We just have to create a Spring MVC controller and we need to annotate it with at REST controller annotation, and within a controller we need to create the Java methods and we need to annotate it with appropriate HTTP annotations. For example, this annotation is used to handle HTTP GET request. So there are a couple of annotations like at post mapping annotation, at put mapping annotation, at delete mapping annotation. So these annotations we use to handle a different HTTP request like HTTP GET request, post request, delete request, put request, isn't it? Well, we'll see how we can use all these annotations in upcoming lectures. In next lecture, we'll create a Spring Boot REST API. It returns a Java bean as a JSON to the client. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we'll create a Spring Boot REST API that returns Java bean as a JSON to the client. Well, let's go to IntelliJ IDEA. In previous lecture, we have created a simple Spring Boot Hello World REST API, and this REST API returns a Hello World string to the client. Well, in real-time projects, we create the REST APIs that returns a JSON to the client, right? So in this lecture, we will see how to create a simple Spring Boot REST API that returns a Java bean as a JSON to the client. Well, it's pretty simple. Just follow the steps that I'm going to implement in this lecture. So first step is we need to create a Java bean. So go to main package and let's quickly create a new package and let's call it as bean. And within a bin package, let's create a Java class. Let's call it as student. And let's go and let's define instance variables for this student class. So let's have a private string student first name, and then private string student last name, and also let's add a id to this student class. So let's say private int id. So this is a student id, this is a first name, this is a last name. Alright, perfect. Next, let's go ahead and let's create a parameterized constructor for this student class. Well, in order to create a constructor, right click on this class, generate, and then constructor, and select all the fields, and then click on OK. Now we have created a parameterized constructor for this student class. Next, let's go ahead and let's also create a getter setter methods for these instance variables. So in order to create a getter setter methods, right click on the class, generate, and choose getter and setter, and select all the fields, and click on OK. Now we have created getter setter methods for these instance variables. Alright, perfect. Now we have created student as a Java bean, and whenever we develop the REST API, we use this student Java bean as a response, and then Spring MVC will convert this Java bean, Java object into a JSON, and it will send that JSON back to the client. So this is the first step, that is we have created a student Java bean. Second step is we need to create a Spring MVC controller. We'll go to controller package, right click on it, new, and then choose Java class, and let's give controller name as student controller. And let's go and let's annotate this class with @REST controller annotation to make this class as a Spring MVC REST controller. This is the second step, that is we have created student controller class. Third step is we need to create the Spring Boot REST API that returns Java bean as a JSON to the client. Well, creating REST API using Spring Boot is very simple. We just have to create a Java method, and we need to annotate that Java method with the Spring annotations. Alright, so here within a student controller, let's create a Java method first. Let's type public, and let's give return type of the method as student, and let's give method name as get student, and then let's create a student object over here, student equal to new student, and let's pass a value to the constructor, id as a 1, and then name as first name as let's say Ramesh, and then last name let's say Padhare. Perfect. Now we have created student object. Next, let's return this student object. Perfect. Now we have created a simple Java method. It returns a student object. Next, let's go ahead and let's make this Java method as a REST API using Spring annotation. Well, this method is going to be handle HTTP GET request. Hence, we are going to use @GET mapping annotation over here. We use @GET mapping annotation to map incoming HTTP GET request with this method. Next, let's go and let's configure the URL for this REST API. So here we just need to pass the URL. For example, let's say student. Well, whenever client want to call this REST API, then client have to use this URL. For example, http localhost :8080 followed by the URI, that is student. Alright, so whenever client want to call this REST API, then client have to use this URL. Next, let's go ahead and let's run the Spring Boot application, and let us test this REST API. So let me start the Spring Boot application. Well, notice here our Spring Boot application is up and running in embedded Tomcat server on port 8080. Well, let me copy this URL to access this REST API, and we can use a browser to make HTTP GET request. So in a new tab, just paste this URL and hit enter, and there we go. The client got a response in a JSON format. Alright, so this is how we develop the Spring Boot REST API that returns Java bean as a JSON to the client. Alright, perfect. Now let me recap what we have done in this lecture. First, we have created student Java bean. Next, we have created student controller, and within a student controller we have created a REST API that returns a student object as a JSON to the client. Alright, it's pretty simple, isn't it? In next lecture, we'll see how to create a Spring Boot REST API that returns a list as a JSON to the client. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we'll create a Spring Boot REST API that returns a list as a JSON to the client. Well, let's go to IntelliJ IDEA, and in previous lecture we have created a REST API that returns a student object as a JSON to the client. In this lecture we will write a REST API that returns a list of students as a JSON to the client. So go to student controller class, and within a student controller class we are going to write the REST API. So here let's first create the Java method that returns a list of students, and then we will make that Java method as a REST API by using Spring annotations. So here just type public and then return type of the method as a list of type student. Alright, and next let's give method name as get students. Let me first create a list of type student, and let's call it as students equal to new array list. And next let's add a student to this list. So here students dot add student and then new student. Let's give ID as a 1 and then first name Ramesh and then last name Padhatari. Next let's add one more student, students dot add and then new student, and let's pass value to this constructor, ID as a 2 and then first name let's say Umesh and last name let's say Padhatari. Perfect. Next let's go ahead and let's add one more student. Let's say student dot, let's call add method and then new student, and let's pass value to the constructor, ID as a 3 and then first name let's say Ram and then last name let's say Jadhav. Next let's add one more student, students dot add and then new student, and let's give ID as a 4 and then first name as a Sanjay and let's give last name as a Pawar. Perfect. Now we have added 4 students to the students list. Next let's return this students object. Perfect. Now we have created a simple get students Java method. It returns a list of students. Next let's make this get students method as a REST API by using Spring annotation. Let's go ahead and let's annotate this method with @getMapping annotation. Well, we use @getMapping annotation to map the incoming HTTP GET request to this method, and this method should return a list of students as a JSON to the client. Next let's configure the URL for this REST API. So here let's pass students. So this is going to be a students because this REST API returns a list of students. So whenever a client want to call this REST API, then client have to use this URL. For example, localhost :8080/students. Alright, perfect. Now let's go and let's run our Spring Boot application and let us test this REST API. So let me start the Spring Boot application. Well, notice here our Spring Boot application is up and running in embedded Tomcat server on port 8080. So let me copy this URL, and this REST API is going to handle HTTP GET request. So we can make a GET request from the browser. So let's go to browser, and in a new tab just paste this URL and hit enter, and there we go. You can able to see the client got a response that is a list of students in a JSON format. This is how we create a Spring Boot REST API that returns a list in a JSON format. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we will create a Spring Boot REST API with path variable. Well, sometime client sends a request and the URL contains a path variable. Well, in this lecture, I want to show you how to create a REST API that handles a path variable in a request. Okay, so basically Spring provides @path variable annotation to handle a path variables in a request URL. Alright, so let's go and let's create a Spring Boot REST API that handles a path variable in a request URL. So let me go to IntelliJ IDEA over here and go to student controller, and here let me write the Spring Boot REST API that handles path variable in a request URL. So here let me write the command Spring Boot REST API with path variable. Next let's create a method and let's make that method as a REST API. So just type public and then let's give student as a return type of the method, and let's give method name as student path variable. Alright, and let's pass student ID as a method parameter, integer ID. Perfect. Next, let's return a new student and let's pass this ID as a parameter, and let's give first name as Ramesh and last name as Padthari. Perfect. So if you can notice here, we are passing this ID dynamically to this student. Okay, now we have created a method. Now let's make this method as a REST API by using Spring annotation. So here we are going to use add get mapping annotation to map incoming HTTP GET request to this method. Next, let's configure the URL for this REST API. Within a double quote, students slash within a curly braces student ID. Well, notice here the ID. So this ID is called URI template variable. Okay, for example, let me write the comment over here. So this ID is called URI template variable. Alright, and sometimes client sends a request something like this. For example, let me copy paste over here and then let's pass the path variable 1. So 1 is nothing but here student ID, and whenever client sends request with URL like this, then this one value will be stored in this URI template variable. Okay, now we need to bind the value of this URI template variable into the method argument ID. So in order to bind the value from this URI template variable to this method argument, what we can do is we can use add path variable annotation. So let me use add path variable annotation. Okay, perfect. So whenever you want to bind a value of this URI template variable to method argument, then we have to use add path variable annotation. Okay, and sometimes we may give the method argument variable name something like this. For example, let's say student ID. Okay, and you can able to see here URI template variable name is ID, but the method argument name is student ID. Both are different, right? So in this case, what you can do is you can just pass a URI template variable name to this add path variable annotation. Then only we can able to bind the value of URI template variable into this student ID. Otherwise, it will give exception. Remember, whenever you have the same variable name, that is URI template variable name and method argument, then you don't have to pass this ID. Okay, otherwise you need to pass this URI template variable to bind a value from this URI template variable to method argument. Okay, next you can pass this student ID over here. Alright, great. Next, let's go and let's run the Spring Boot application and let's see how this REST API works. So let me stop the existing server. Let me start the Spring Boot application. And there we go, our Spring Boot application is up and running. Next, let me copy this URL. Well, this is the get REST API, so we can access this REST API from the browser. So let's go to browser and let me paste this URL in a new tab and hit enter, and there we go. You can able to see the ID is dynamically assigned to this student ID. Okay, if I pass here 2, then this will give a response as a ID 2. Okay, so this is how basically client sends a request with a URL like this, and this URL contains a path variable, and in order to get the value of this path variable, we have to use add path variable annotation. Well, we can also pass a multiple path variables in a URL. For example, consider this is the URL and here we have passed student ID as a path variable. Next, we can also pass student post name as a path variable as well as student last name as a path variable. Alright, and next here we need to change the URL along with ID. We need to also have a URI template variable, that is first name, post hyphen name, and then similarly last hyphen name. Alright, so this is a basically naming convention that typically we use whenever we have a variable that contains 2 words. Okay, next, in order to bind a value of these 2 template variables, we have to use add path variable annotation. So here let me first pass the method argument to this method, string first name and then string last name. Okay, next let's use add path variable annotation to bind the value of this URI template variable to this method argument, and we need to pass this URI template variable name to this add path variable annotation. Okay, perfect. Next, let's do it for last name as well. So let's use add path variable annotation, and then within a braces just pass this URI template variable name. Okay, and next let's remove this hard code and let's pass first name, and let's also remove this hard code value and let's pass last name. Okay, this is how we write a REST API to handle multiple path variables in a request URL. Alright, great. Next, let's run our Spring Boot application and let's test this REST API. So let me stop the existing server. Let me start the Spring Boot application. Alright, and let's go to browser, and here along with student ID, let's also pass first name and last name. So let me give admin as a first name and administrator as a last name. Okay, and hit enter, and there we go. You can able to see ID 1, first name admin, last name administrator. So let me pass some different values. Student ID 2, first name Umesh, last name Padatare, and there we go. You can able to see we got a response, and these values are updated in a response. Alright, so this is how we create a Spring Boot REST API. It handles a path variables in a request URL. Alright, great. In next lecture, we will see how to create a REST API that handles a query parameters in a request URL. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we will create a Spring Boot REST API with request parameter. Well, sometime a client sends a request. The request URL contains a query parameters, right? So in this lecture, we'll see how to use @request_param annotation to extract query parameters from the request URL. So let's go to IntelliJ IDEA and let's quickly create the REST API that handles query parameters in a request URL. So within a student controller, let me write the REST API over here. So let me first write the comment Spring Boot REST API with request param. Well, sometimes client sends a request something like this. For example, let me first construct the URL. Consider in a request URL, we got the URL something like this, localhost 8080/students, and then question mark ID equal to 1. So this is basically called a query parameter. Okay, now let's go and let's write the REST API to handle this kind of request URLs. So let me create the method first, public, and let's give return type of the method as a student, and let's give method name something like student request variable. Alright, and let's pass ID as a method argument, integer ID. Next, let's return a new student and then pass ID dynamically, and let's give first name as Ramesh and let's give last name as Padatari. Perfect. Now we have created a method. Let's make this method as a REST API by using Spring annotations. So here let me use add_get_mapping annotation. Well, we use add_get_mapping annotation to map incoming HTTP GET request to this method. Next, let's configure the URL. So let's give URL something like this, students, and then query. Well, we have already a students URL we have configured for this REST API, right? So the REST API URL should be unique. That's why I am using query over here, and here also we need to pass /query to this URL. Okay, great. Now whenever client sends a request with a URL like this, then we need to get the query parameter from the URL by using @request_param annotation. Okay, so basically we need to bind the value of this query parameter to this method argument, and in order to do that we can use @request_param annotation. Okay, perfect. Next, let's go and let's run our Spring Boot application and let's see how this REST API works. So let me start the Spring Boot application, and there we go, our Spring Boot application is up and running. Next, let's copy this URL. Well, this REST API handles HTTP GET request, so we can use a browser to call this REST API. So let me go to browser, and in a new tab just paste this URL and hit enter, and there we go. You can able to see the REST API return the JSON, and you can able to see the ID is dynamically updated. If you pass 2 here, then we get ID 2. Okay, it means that the REST API that we have created to handle query parameters in a request URL is working as expected. Now let's see how we can handle multiple query parameters in a request URL. For example, let's say if client sends a request with a URL localhost 8080/student/query, and then ID equal to 1 as a query parameter. After that, let's say one more query parameter, for example post name equal to Ramesh, and let's give one more query parameter, let's say last name equal to Padthare. Okay, next here we also need to pass the method argument. For example, string first name and then string last name. Alright, and in order to extract the value from these query parameters, we have to use @request_param annotation. Perfect. Next, let's remove this hardcode value and let's pass post name, and here also let's remove this hardcode value and let's pass last name. Okay, now we have created a REST API that handles multiple query parameters in a request URL. Right, next let's run our Spring Boot application and let's see how this REST API works. So let me start the Spring Boot application. Alright, and let's go to browser. Here let me create the proper URL, ID equal to 2, and then ampersand post name equal to Ramesh, ampersand last name equal to Padthare. Hit enter, and there we go. You can able to see client got the response, and in a response you can able to see post name Ramesh, last name Padthare, ID 2. So if I change the query parameter values over here, for example last name let's say Jadhav, and post name let's say Ram, and ID let's give 1, and hit enter, and there we go. In a response you can able to see the query parameter values are successfully updated. Alright, it means that the REST API that we have created to handle multiple query parameters in a request URL is working as expected. Alright, so this is how basically you write a Spring Boot REST API to handle query parameters in a request URL. Now you might be wondering what is the difference between @path variable annotation and @request_param annotation. Well, path variable annotation is used to bind the value of URI template variable into method argument, and we use @request_param annotation to extract the value of query parameters in a request URL. Alright, so this is the main difference. I hope you understood how to create a Spring Boot REST API that handles multiple query parameters in a request URL. Alright, great. I will see you in the next lecture. We'll learn how to build the crude RESTful web services using Spring Boot, Hibernate, and PostgreSQL database. In this project, we are going to use 3-layer architecture: controller layer, service layer, and repository layer. At a database level, we are going to use PostgreSQL database. And controller layer basically holds the REST APIs, and that will handle all the requests that comes from the client. Next, service layer basically holds the business logic of the application. Next, repository layer holds the database related logic, and it is responsible to talk with the database. And in this tutorial, we are going to use Postman client to test the REST APIs. And in this project, we are going to use the latest version of Spring Boot, Hibernate, Spring Data JPA, PostgreSQL database, Maven, Java. Okay, we are going to use the latest version of all the tools and technology. Without further ado, let us start creating the Spring Boot application. Hi everyone, welcome back. In this lecture, we are going to create and set up Spring Boot project in IntelliJ IDEA. Well, first, we'll create a Spring Boot project using Spring Initializer, and then we'll import that project in IntelliJ IDEA. So let us first go ahead and create a Spring Boot project using Spring Initializer. Well, here I am in a Chrome browser. In a new tab, just type start.spring.io. This will bring up Spring Initializer. Well, Spring Initializer is a tool that we can use to quickly create a Spring based application. So here, let us fill up the project information. So here we have different types of projects. So let us select Maven over here, and here we have different JVM languages, Java, Kotlin, Groovy. So let us keep Java as selected over here. Next, let us choose Spring Boot version. Well, here you can see by default 3.1.0 is selected, but whenever you create a Spring Boot project, then that time the Spring Boot version may be different. And let us keep the default one selected as it is, because this is a stable and latest release of Spring Boot. Next, let us fill up the project metadata over here. So let us give group as net.javaguides. You can give any group that you want. Next, artifact. So let us give artifact as EMS Backend. So here we are developing employee management system. That's why the name EMS and then Backend. Next, project name is same as artifact. Next, let us give description as demo project for Spring Boot employee management system. Next, package net.javaguides.ems. Packaging, let us keep jar as selected. Next, Java version 17. Well, remember, whenever you choose Spring Boot 3, then make sure that you choose Java version 17 or later. Next, let us go ahead and let us add the dependencies. So go ahead and click on add dependencies over here, and here just type web. Well, we use Spring Web dependency to build web applications as well as RESTful web services, and this Spring Web dependency internally provides Apache Tomcat as a default embedded container. Alright, so whenever you want to develop the Spring Boot RESTful web services, then make sure that you choose Spring Boot starter web dependency. Next, let us go ahead and let us select Spring Data GPA dependency. Well, we want to use Spring Data GPA dependency to develop the persistence layer or the repository layer, and Spring Data GPA internally uses Hibernate as a JPA provider, and Spring Data GPA, it reduces a lot of boilerplate code that is required to develop the repository layer. So let us go ahead and select Spring Data GPA over here. Next, let us add a PostgreSQL JDBC driver dependency. Well, PostgreSQL driver is a JDBC and R2 JDBC driver that allow Java programs to connect to a PostgreSQL database using standard database independent Java code. Next, let us add a Lombok annotation. So here just type Lombok. So Lombok is a annotation based library which helps to reduce the boilerplate code. So let us select Lombok dependency over here. So as of now, let us keep these 4 dependencies for this Spring Boot application. And next, go ahead and click on generate button over here. So this will generate the Spring Boot application as a zip file, and it will download it in a file system. Okay, next let us go ahead and let us open this zip file in a folder. Alright, next let us go ahead and let us unzip this zip file. Perfect. Next, let's open the IntelliJ IDEA over here, and here you can see we have 3 options: new project, open, get from VCS. So we are going to open the existing Maven project. So let us click on open button, and next go to the location where your Spring Boot application is present. So in my case, it is in download folder, and here let me select EMS backend project, click on open. Now we have opened Spring Boot application in IntelliJ IDEA. Well, let me recap what we have done in this lecture. We have created Spring Boot project using Spring IntelliJ, and then we have imported that project in IntelliJ IDEA. In next lecture, we will configure PostgreSQL database in our Spring Boot application. Alright, yet I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we will configure PostgreSQL database in our Spring Boot application. Well, in order to connect our Spring Boot application with the PostgreSQL database, we have to configure the PostgreSQL database details in a Spring Boot application. So let's go to our Spring Boot application, go to application.properties file. So before configuring PostgreSQL database details over here, let's first create a PostgreSQL database. So let us head over to pgadmin4. This is the console to connect to the PostgreSQL server. So here right click, create a database. Let's give a database name as EMS. EMS stands for Employee Management System. So let us keep default and click on save. This will create a EMS database in a PostgreSQL server. Okay, next let's configure this EMS database in our Spring Boot application. So let's go back to IntelliJ IDEA, go to application.properties file. Here let us type the property spring.datasource.url. Next let us give the JDBC URL, JDBC colon PostgreSQL localhost. Well, the PostgreSQL server is running on local machine, that's why localhost, and the default port 5432 followed by the database name. So this is the JDBC URL to connect our Spring Boot application with the PostgreSQL database. Next, configure the username spring.datasource.username Postgres. Next, similarly, let's configure the PostgreSQL database password spring.datasource.password Postgres. Well, in my case, the username and password are same, so make sure that whatever the username and password you have given while installing the PostgreSQL database, you have to mention over here. Alright, next let's configure one more property spring.jpa.hibernate.ddl-auto equal to update. Well, this property is pretty useful. This property basically tells Hibernate to automatically create the database tables. Okay, so we don't have to manually create the database tables. Hibernate will automatically generate the database tables based on the JPA entities. In next lecture, we will create a employee JPA entity. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we are going to create an employee JPA entity. So let's go to our project in IntelliJ. And here, before creating the employee JPA entity, let's quickly create a packaging structure for our Spring Boot application. So go to base package over here, right click, new, and then choose package. Let's give package name as entity. Next, let us create one more new package. Let's call it as controller. Within a controller package, we keep all the Spring MUC controllers, and within an entity package, we keep all the JPA entities. Next, let's create one more package. Let's call it as repository. Within a repository package, we keep all the Spring Data JPA repositories. Next, let's create one more package. Let's call it as service. Within a service package, we keep all the interface and classes that are related to service layer. Next, let's create one more package. Let's call it as DTO. Within DTO package, we keep all the DTO classes. Next, let us create one more package. Let's call it as exception. Within exception package, we keep all the custom exceptions. Alright, so as of now, let us keep these packages. Next, go to entity package, right click on it, new, and then choose Java class. Let us give class name as employee. Alright, next, let us go ahead and let us add the instance variables to this class. So here private long ID, and then private string first name, and then private string last name, and then private string email. Perfect. Next, let us go ahead and let us use Lombok annotations to reduce the boilerplate code. So here let us use add getter Lombok annotation to generate a getter methods for these instance variables. Next, let us use add setter Lombok annotation to generate a setter methods for these instance variables. Next, let us use add no argument constructor annotation to create a no argument constructor. Next, let us use add all args constructor to create a parameterized constructor. Okay, now we have created employee Pojo class. Let us make this employee class as a JPA entity by using JPA annotations. So let us annotate this class with add entity annotation from jakarta.persistence package. Well, we use add entity annotation to specify a class as a JPA entity. Next, let us annotate this class with add table annotation from jakarta.persistence package. Well, we use add table annotation to specify the table details. So here let us use name attribute to specify the table name. So let us give table name as employees. Perfect. Next, let us configure the primary key for this employee entity. So here let us annotate the ID field with add ID annotation. So make sure that you choose ID annotation from jakarta.persistence package. Next, let us configure the primary key generation strategy. For that, let us use add generated value annotation. And next, add generated value annotation has a strategy attribute. So here let us configure the primary key generation type. So here let us use add entity. So this add entity primary key generation strategy basically uses database auto increment feature to automatically increment the primary key. Okay. Next, let us use add column annotation to map a database table column with a class field. For example, here let us have a column mapping for this first name field. So let us annotate this first name field with add column annotation from jakarta.persistence package, and let us give the column name first underscore name. So this column name will be mapped with the first name field. Okay, perfect. Well, if we don't specify add column annotation, then by default JPA will give the column name as field name. Okay, but the column name like first underscore name makes sense. That's why here we are using add column annotation to explicitly configure the column name for this field. Okay, perfect. Next, let us annotate last name field with add column annotation, and let's give column name as last underscore name. Next, let us annotate email field with add column annotation, and let us give a column name as email underscore ID. Next, let us make this email underscore ID column as a not null by using nullable equal to false attribute, and we can also make this email as a unique by using unique equal to true. Alright, now we have created employee JP entity. Next, let us run our Spring Boot application and let us see whether Hibernate will automatically create this employees table in a database or not. So let's go to main point class over here. From here, let us rerun the Spring Boot application. Next, let us go to the pgadmin 4 and let us see whether the employees table is created in a PostgreSQL database or not. So let us head over to pgadmin 4 here and go to EMS database, refresh, and go to schemas. Within a schemas, go to public, and within a public, go to tables, and within a tables, you can see employees table is successfully created. Next, right click on employees table and click on view data, and notice here the employees table has a column ID, email ID, first name and last name. Okay, it means Hibernate successfully created employees table in a PostgreSQL database. In next lecture, we will create a employee repository for this employee entity. Alright, I will see you in the next lecture. Hi everyone, welcome back. In previous lecture, we have created employee JP entity. In this lecture, we are going to create employee repository. So let's go to our project in IntelliJ idea and go to repository package over here. Right click on repository package, new, and then choose Java class. Select interface. Let us give interface name as employee repository. Next, let us extend this employee repository interface from JPA repository interface and make sure that you choose JP repository interface from org.springframework.data.jpa.repository package. Well, notice here JP repository is a generic interface, so we have to pass two parameters. First parameter is the type of the entity, second parameter is the type of the primary key. So let us select JPA repository over here and let us pass the parameters. First parameter as a type of the entity, in our case employee entity. Next, let us pass the type of the primary key, that is long. Well, if you go to employee JP entity, you can see here we have given the type to the primary key ID as a long. So this long data type we are passing to JP repository as a second parameter. Okay, perfect. Well, once our employee repository interface extends JP repository interface, then this employee repository will get a CRUD methods to perform CRUD database operations on this employee JP entity. Alright, so if you go to JP repository interface source code, you can see JP repository interface provides these methods, and again JP repository interface extends list CRUD repository interface, and list CRUD repository interface provides all these methods. And this list CRUD repository method internally extends CRUD repository interface, and this CRUD repository interface exposes CRUD methods to perform CRUD database operations. Alright, it means this JPA repository will inherit all the methods from all the extended interfaces. And again, Spring Data JPA will provide the implementation for this JPA repository interface. For example, if you click on this, you will get the implementation classes. And here simple JPA repository is a class that implements all the methods of JPA repository interface and its child interfaces. So just click on simple JPA repository class over here, and you can see simple JPA repository class implements JPA repository implementation interface, and this interface internally extends JPA repository interface. It means simple JPA repository indirectly implements JPA repository interface and its methods. Alright, and if you can notice here, simple JP repository class, it is already annotated with add repository annotation. So we don't have to annotate our repository interface with add repository annotation. For example, if you go to employee repository, we don't have to annotate this employee repository interface with add repository annotation, because the implementation class, that is simple JP repository class, is already annotated with add repository annotation. And here one more important point is simple JP repository class annotated with add transactional annotation. It means all the methods in a simple JP repository class are by default transactional. We don't have to use again add transactional annotation in a service layer to make the methods as a transactional. Okay, for example, if you just scroll down, you can see delete by id method is a transactional because it is annotated with add transactional annotation, and delete method is a transactional because it is annotated with add transactional annotation. Alright, so all the public methods in a simple JP repository class are transactional, so we don't have to again use add transactional annotation to make these methods transactional. Alright, just remember these couple of important points, like simple JP repository is a class that implements JP repository interface, and simple JP repository class it is already annotated with add repository annotation, so we don't have to again annotate our repository interfaces with add repository annotation. And simple JP repository class is annotated with add transactional annotation, so all the methods, all the public methods in a simple JP repositories are by default transactional. We don't have to again make those methods transactional by using add transactional annotation. Alright, perfect. So let me recap what we have done in this lecture. We have created employee repository interface that extends JP repository interface. So this employee repository will get CRUD methods to perform CRUD database operations on employee JP entity. In next lecture, we will create an employee DTO and employee mapper classes. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we will create an employee DTO and employee mapper classes. So let's go to our project in IntelliJ IDEA and go to DTO package over here. Right click on DTO package, new, and then choose Java class. Let's give class name as employee DTO. Perfect. Next, let us define the instance variables for this class. So here private long id, and then private string first name, and then private string last name, and then private string email. Next, let us annotate this class with add getter lombok annotation to generate the getter methods for these instance variables. Next, let us use add setter lombok annotation to generate the setter methods for these instance variables. Next, let us use add no argument constructor and add all argument constructor annotations to create a constructors for this class. Well, we use the employee DTO class to transfer the data between client and server. So when we build the RESTful web services, we'll use this employee DTO as a response for REST APIs. Next, let us create an employee mapper class to map employee entity to employee DTO and employee DTO to employee entity. So whenever we build the RESTful services, then we have to convert employee DTO into employee JP entity and employee JP entity into employee DTO, right? So instead of writing the same logic in all the classes, let's create a mapper class and let's keep the common logic. So here what we'll do, we'll create a new package and let's call it as mapper. Let's create a class. Let's give a class name as employee mapper, and next let us create a static method, public static. Let's give return type as employee DTO, and let's give method name as map to employee DTO, and let us pass employee JP entity as a parameter to this method. And next here return new employee DTO, and let us pass the values to the constructor. So let us get all the values from employee JP entity and let us set those values to the employee DTO. So here employee dot get ID, and then employee dot get first name, employee dot get last name, employee dot get email. Perfect. Now we have created map to employee DTO method. It will map employee JP entity into employee DTO. Similarly, let's create one more method that will map employee DTO to employee JP entity. So here public static Let us give employee JP entity as a return type. Next, let us give method name as map to employee, and let us pass employee DTO as a parameter to this method. Next, return object. So let us construct the object of employee JP entity, and here employee DTO.get ID, employee DTO.get first name, employee DTO.get last name, employee DTO.get email. Alright, perfect. Now we have created map to employee static method. It convert employee DTO into employee JP entity. Alright, perfect. So let me recap what we have done in this lecture. We have created employee DTO class to transfer the data between client and server, and next we have created employee mapper class to map employee entity to employee DTO and employee DTO to employee entity. Alright, great. In next lecture onwards, we will start building the RESTful web services. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we will build add employee REST API. Well, let us take a look into the development steps. First, we will create the service layer. Well, if you can see here, the controller layer depends on service layer, and the service layer depends on a repository layer, and we basically create the REST APIs in a controller layer, right? So controller layer depends on service layer. So let us first create the service layer. Well, we have already created the repository layer, so we don't have to write any methods in a repository layer as of now. So let us first create the service layer, and then we'll build the REST API in a controller layer. Okay, so create the service layer, like we'll create an employee service interface, and then we create an employee service IMPL class that implements employee service interface. Next, we'll build the add employee REST API in a controller layer, and next we'll test this add employee REST API using Postman client. Okay, so let us go to our project in IntelliJ idea. And here let us first create the service layer. So go to service package, right click on it, new, and then choose Java class, select interface. Let us give interface name as employee service. Within employee service interface, let us define the method. So let us give method return type as employee DTO. Let us give method name as create employee, and let us pass employee DTO as a parameter to this method. Perfect. Next, let us create employee service IMPL class that implements this interface and its methods. Next, go to service package, right click on this package, new, and then choose package. Let's give package as IMPL. IMPL stands for implementation. So right click on IMPL package, new, and then choose Java class. Let's give class name as employee service IMPL. Perfect. Next, this class implements employee service interface. And next, go ahead and mouse over on this class, and here you will get the option to implement the methods like the link. So go ahead and click on this implement methods link over here and select the method that you want to implement. Click on OK. Perfect. Next, let us annotate this class with @service annotation, and make sure that you choose service annotation from org.springframework.stereo.package. Well, this annotation tells Spring container to create the Spring Bean for this class. Next, let us implement create employee method. Well, before implementing this method, let us first inject the dependencies. So here, private employee repository. Well, we are going to use constructor based dependency injection to inject the dependencies, and instead of creating the constructor manually, let us use Lombok annotation. So let us annotate this class with @all-argument constructor annotation. Okay, now we have injected employee repository as a dependency. Next, let us implement create employee method. So go to create employee method, and within this create employee method, first we need to convert employee DTO into employee JP entity, because we need to store the employee entity into database, isn't it? So here, let's say employee equal to, let us call employee mapper class to map employee DTO to employee JP entity. So here employee mapper, it has map to employee method and then pass employee DTO. Okay, now we have converted employee DTO to employee JP entity. Next, let us save this employee JP entity into database. So for that, let us call employee repository. It has a save method and then pass employee JP entity object. Perfect. Next, this save method return the saved employee object. So let us get into a local variable. So here employee, and let us give a variable name as saved employee. Next we need to return saved employee object back to the client. So here let us convert saved employee JPA entity into employee DTO. So here let us remove this null and let us type employee mapper. It has map to employee DTO, and let us pass saved employee. Perfect. Now we have implemented create employee method. Next go to controller package over here, right click on controller package, new, and then choose Java class. Let us give class name as employee controller. Next let us annotate this employee controller class with @REST-controller annotation. Well, once we annotate a class with @REST-controller annotation, then this class becomes a Spring MVC REST controllers, and this class is capable to handle HTTP requests. Next let us annotate this class with one more annotation, that is @request-mapping annotation. Well, here we are using @request-mapping annotation to define the base URL for all the REST APIs that we are going to build within this controller. So here let us give the base URL /API/employees. Okay, perfect. Next, within this employee controller, let us first inject the dependencies. So private employee service, and instead of creating the constructor manually, let us annotate this class with @argument constructor annotation. Okay. Next, let us build add employee REST API. So here let me write the comment build add employee REST API. Well, creating a REST API using Spring Boot is very simple. First we need to create a method, and then we'll make that method as a REST API by using Spring annotations. So here let's first create a method public, and let's go return type of the method as a response entity. So response entity is a generic class. We have to pass the type. So here let us pass employee DTO as a type. Next let us give method name as create employee, and let us pass employee DTO as a parameter to this method. And next here let us call employee service. It has create employee method, and then pass employee DTO object as a parameter to this method, and this create employee method returns a saved employee. So here employee DTO, and let us give the variable name as saved employee. Next let us have return statement, return object of response entity. So let us pass value to the constructor. So first value as saved employee, second value as HTTP status code. So here just type HTTP status dot created. Next let us make this method as a REST API by using Spring annotations. So here let us annotate this method with @postmapping annotation. Well, we use @postmapping annotation to map the incoming HTTP post request to this method. Next let us use one more annotation here, that is @requestBody annotation. Well, this @requestBody annotation will extract the JSON from the HTTP request, and it will convert that JSON into employee DTO Java object. Okay, perfect. Now we have created add employee REST API. Next let us run our Spring Boot application, and let us test this REST API using Postman client. So from here I am going to stop and rerun the Spring Boot application. Well, notice here our Spring Boot application is up and running in an embedded Tomcat server on port 8080. Next let's go to the Postman client over here, and here let me create a new request. Let us choose HTTP post method, and let us enter the request URL HTTP localhost 8080/API/employees, and next go to the body, select raw, select content type JSON, and within a body we need to pass the JSON object. So here let's create a JSON object. So first name, let us give first name as Ramesh, and then last name, let us give last name as Padtari, and then email, let us give email as ramesh@gmail.com. Well, if you can go to our project in IntelliJ IDEA and go to create employee REST API, and here you can see employee DTO. And if you go inside employee DTO, and this employee DTO class has the fields first name, last name, email. And if you go to Postman client, and if you can notice the JSON over here, the attributes name like first name, last name, email. So whenever you pass the JSON in the request, make sure that the JSON attributes should be same as the DTO class fields, because we are using @request_body annotation here to extract the JSON and convert that JSON into employee DTO Java class object. And in order to convert a JSON into Java object, the JSON attributes and Java object fields should be same. Okay, perfect. Next, let's go to Postman client over here. Next, go ahead and click on send button, and there we go. We got a response of the REST API, and if you can notice here the status 201 created and the saved employee object in the response. We have successfully built add employee REST API. In next lecture, we will build get single employee REST API. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we are going to build get employee REST API. So let's go to our project in IntelliJ IDEA, and let us first change the service layer, and then we'll change the controller layer, because the controller layer depends on service layer. So let's go to employee service interface over here. Within this interface, let us define the get employee by ID method. So here, let us give employee DTO as a return type of the method, and let us give method name as get employee by ID, and let us pass employee ID as a parameter to this method. Perfect. Now we have defined get employee by ID method in a employee service interface. Next, let us implement this method in employee service IMPL class. So let us go to employee service IMPL class over here, and just mouse over on this class, and here we have implement methods link. So go ahead and click on this link over here, and then select the method that we want to implement. Next, click on OK. Perfect. So here we can implement the get employee by ID method. Well, before implementing this method, let's go ahead and let's first create one custom exception. Well, whenever an employee with a given ID is not exist in database, then we have to throw the custom exception, isn't it? So let us go ahead and let us first create the custom exception. So go to exception package, right click, new, and choose Java class. Let us give exception name as resource not found exception. Perfect. Next, let us extend this class from runtime exception, and then let us create a parameterized constructor public resource not found exception, and then let us pass message as a parameter. Alright, and here let us call super keyword to pass this message to the super class constructor. Next, let us annotate this class with @response status annotation, and let us specify the HTTP status. So here let us give HTTP status not found. Well, if employee with a given ID is not exist in database, then we will throw this resource not found exception, and then Spring Boot will catch this exception, and it will get the error message from the exception, and it will send the error message along with the HTTP status to the client. Next, let us go back to employee service IMPL class over here. Next, let us implement this get employee by ID method. So here, let me maximize this. So within a get employee by ID method, let us call employee repository. It has find by ID method, and notice here find by ID method returns optional of type employee. So let us call find by ID method over here and just pass employee ID. Next, optional has or else throw method. So here let us call or else throw method over here, and notice here or else throw method returns a employee object, and or else throw method takes supplier as a functional interface, and we have to pass the lambda expression implementation of this supplier functional interface. So let us call this or else throw method over here, and let us create the lambda expression. So here lambda symbol, and then new resource not found exception, and let us pass the message employee is not exist with a given ID. Alright, and let us pass the ID dynamically over here. That is employee ID. Perfect. Next, let me maximize this a bit. Next, you can see the typo here exists, so let me correct it. Employee is not exist with a given ID, and then employee ID. Next, let me also break this statement. Perfect. So this or else throw method returns an employee object, So here let us take the result of this or else through method in a local variable of type employee. Perfect. Next, if you can notice here, get employee by ID method returns the employee DTO. So let us convert this employee JP entity into employee DTO. So go to return statement, remove this null, and let's call employee map over here. It has a map to employee DTO method, and then pass employee JP entity object. Perfect. Now we have implemented get employee by ID method in a employee service IMPL class. Next, let us create the REST API that will internally call this get employee by ID method. So here let me minimize this and go to employee controller over here, and within employee controller let us build get employee by ID REST API. So here let me write the comment build get employee REST API. Well, creating a REST API using Spring Boot is very simple. We just need to create a method and then we will convert that method into REST API by using Spring annotations. So here let us first create a method public and then response entity as a return type. Response entity is a generic, so let us pass employee DTO as a type. And next let us give method name as get employee by ID. Next let us pass employee ID as a parameter to this method. Within this get employee by ID method, let us call employee service. It has get employee by ID method and then pass employee ID. Perfect. So this get employee by ID method returns employee DTO. So here let us take the result of this method in a local variable of type employee DTO. Perfect. Next let us have a return statement. Return response entity. It has a OK method. And next let us pass employee DTO as a parameter to this method. Perfect. Now we have created get employee by ID method. Next let us make this method as a REST API by using Spring annotations. So here let us annotate this method with add get mapping annotation. Well, we use add get mapping annotation to map the incoming HTTP GET request to this method. Next let us pass the ID. Well, this ID is basically called a URI template variable. Next we need to bind the value of this URI template variable to this method argument. So in order to do that, we have to use add path variable annotation. So here let us use add path variable annotation, and we need to also pass the URI template variable name here, that is ID. So notice here the URI template variable name is ID and the method argument name is employee ID. So both the variable names are different. That's why we have to pass the URI template variable name to the path variable annotation. Then only the path variable annotation will bind the value of this URI template variable to this method argument. Okay, perfect. Now we have created get employee REST API. Next let us rerun our Spring Boot application and let us test this REST API using Postman client. So from here I want to stop and rerun the Spring Boot application. Well, notice here our Spring Boot application is up and running in embedded Tomcat server on port 8080. Next let us go to Postman client over here and let us create a new request, and here let us choose HTTP GET method and let us enter the request URL HTTP localhost 8080/API/employees and then /1, and here we have passed employee ID 1. Okay, next click on send button and there we go. You can see the response. The REST API returned the response and the response contains the employee object in a JSON format and the status 200 OK. It means we have successfully built get employee REST API. In next lecture we are going to build get all employees REST API. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture we are going to build get all employees REST API. So let's go to our project in IntelliJ IDE over here, and first we will change the service layer and then we will change the controller layer because the controller layer depends on service layer. So let us go to employee service interface over here, and within this interface let us define the method. So let us give a return type of the method as list of employee DTO. Next let us give method name as get all employees. Alright, now we have created get all employees method in our employee service interface. Next let us implement this method in our employee service IMPL class. Let us head over to employee service IMPL class over here and just mouse over on this class, click on this implement methods link. Next let us select the method that you want to implement, click on OK. Alright, now let us go ahead and let us implement this get all employees method over here. Within a get all employees method, let us call employee repository. It has find all method. We'll notice here there are multiple overloaded find all methods. Where I want to choose the find all method, it doesn't take any method argument, and find all method returns a list of type employee JP entity. Okay, so let us select find all method over here. Next, let us take the result of this find all method in a local variable of type list. So here let us declare list. List is a generic. Let us pass employee class as a type and let us call it as employees. Perfect. Now we have list of employee JP entities, but if you can see here, get all employees method returns list of employee DTOs, right? So let us convert a list of employee JP entities into list of employee DTOs. So here go to return statement, remove this null, and here just call employees. So employees is a list. It has a stream method, and then stream has a map method, and notice here map method has a function as a functional interface, and we need to provide the lambda expression implementation for this functional interface. So let us select map method over here. So basically we use map method to map one object into another object, and in our case we have to convert employee JP entity into employee DTO, right? So here let us have a lambda expression implementation. So here let us pass employee as a parameter, and let us have lambda symbol, and then call employee mapper. It has map to DTO method, and then pass employee object. Perfect. And finally let us call collect method to collect the result. So here we are using list, so let us call this collect method. It takes to list as a parameter. Now we have written a logic to convert a list of employee JP entities into list of employee DTOs. Next, let us create the REST API that will internally call this method. So go to employee controller over here, and within employee controller, let us build get all employees REST API. So here, let me write the comment, build get all employees REST API. Well, creating REST API using Spring Boot is very simple. First, we need to create a method, and then we'll convert that method into REST API by using Spring annotations. So here, let us first create the method public response entity as a return type. Response entity is a generic, so let us pass list as a type. List is also a generic interface. Let us pass employee DTO as a type, and let us give method name as get all employees. Alright, and here let us call employee service. It has get all employees method. So get all employees method returns a list of employee DTOs. So here let us declare a local variable of type list. List is generic. Let us pass employee DTO as a type, and let us give variable name as employees. Perfect. Next, let us have return statement, return response entity, and then call its OK method, and then pass employee objects as a parameter. Perfect. Now we have created get all employees method. Let us make this method as a REST API by using Spring annotations. So here let us annotate this method with add get mapping annotation. Well, we use add get mapping annotation to map incoming HTTP GET request to this particular method. Alright, perfect. Now we have built get all employees REST API. Next, let us rerun our Spring Boot application and let us test this REST API. So from here, I am going to stop and rerun the Spring Boot application. Well, our Spring Boot application is up and running in embedded Tomcat server on port 8080. Next, let us go to Postman client over here. And here, let me copy this URL and let me create the new request. Let us choose HTTP GET method and let us enter the URL. Localhost 8080/API/employees. Click on send button, and there we go. You can see the array contains a single JSON object. So let us insert one more employee. So go to add employee request over here, and let us change the JSON. Post name, let us say Sanjay. Last name, let us say Jadhav. Email sanjay@gmail.com. Next, click on send button, and there we go. We got the response and the status code 201 created. Next, let us go to get all employees request over here, and then click on send button, and there we go. You can see here there are total 2 employees, and in a response also there are 2 employees. Next, let us insert one more employee. So go to post request, and here let us give first name as Tom and last name Cruz, email tom@gmail.com. Click on send button, and there we go. We got the response with the employee ID 3. Next, let us go to get all employees request over here. Click on send button, and there we go. You can see a Tom employee is present in a array. Okay, it means we have successfully built get all employees REST API. In next lecture, we will build update employee REST API. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we are going to build update employee REST API. So let us go to our project in IntelliJ IDEA. Well, first we're going to change the service layer, and then we'll change the controller layer, because the controller layer depends on service layer. So let us go to employee service interface over here. Within this interface, let us define the method. So here let us give employee DTO as a return type of the method, and let us give method name as update employee, and let us pass employee ID as a post parameter and employee DTO as a second parameter. And this employee DTO basically contains the updated employee details. Okay, so let us call it as updated employee. Okay, perfect. Now we have defined update employee method in an employee service interface. Next, let us implement this method in an employee service IMPL class. So let us go to employee service IMPL class over here. Just mouse over in this class, click on this implement methods, and then click on OK method. Now let us go and let's implement update employee method. Within update employee method, let us first add the validation, like if employee with a given ID is not exist in database, then we have to throw the resource not found exception, isn't it? So let us write that logic here. So just call employee repository. It has find by ID method, and notice here find by ID method returns optional of type employee. So let us call find by ID method over here, and then pass employee ID as a parameter, and then optional has or else throw method. So let us call or else throw method over here, and notice here or else throw method takes supplier as a functional interface, and we have to provide the lambda expression implementation for this supplier functional interface. So just call this method, and then let us construct the lambda expression. So here new resource not found exception, and then let us pass the custom exception message. Let us say employee is not exist with given ID, and then pass employee ID dynamically. Perfect. Next, let me put the semicolon over here. Alright, and this or else throw method returns a employee object. So here let us take the result of or else throw method in a local variable of type employee. Perfect. Next, we have the updated employee object. It contains all the employee updated information. So let us set all the details from updated employee object into this employee object. Okay, so here employee dot set first name, and then updated employee dot get first name, employee dot set last name, and then updated employee dot get last name, employee dot set email, and then updated employee dot get email. Perfect. Next, let us call employee repository. It has a save method, and then pass this employee object. Okay, so here basically we have updated this employee object with first name, last name, email, and again we are saving this employee object by using save method. So basically this save method performs both save and update operation. Well, if employee object contains ID, then this save method internally perform the update operation, and if employee ID doesn't contain the primary key ID, then it will perform the insert operation. Alright, next this save method returns the updated employee object. So here let us declare the updated employee object like this. Perfect. Next, if you can see here, update employee method returns the employee DTO. So let us convert this updated employee object JP entity into employee DTO. So here go to return statement, remove this null, and then call employee mapper. It has map to employee DTO method, and then pass updated employee object as a parameter. Now we have implemented update employee method in a employee service IMPL class. Next, let us create the REST API that will internally call this update employee method. So go to employee controller over here. Within employee controller, let us build update employee REST API. So here, let me first write the comment build update employee REST API. Let us first create a method and then we'll convert that method into REST API by using Spring annotations. So here just type public response entity and then pass employee DTO as a type. Let us give method name as update employee. Alright, and let us pass employee ID as a first argument and employee DTO as a second argument. So this employee DTO is nothing but updated employee information. Perfect. Next, let us call employee service. It has update employee method and then pass employee ID as a first parameter, updated employee as a second parameter. Perfect. Next, this update employee method returns the employee DTO. So here let us have a local variable of type employee DTO. Alright, next let us have a return statement, return response entity and then call OK method and then pass employee DTO. Alright, now we have created update employee method. Let us make this method as a REST API by using Spring annotations. So let us annotate this method with @putMapping annotation. Well, we use @putMapping annotation to map incoming HTTP put request to this method. Next, let us pass the ID. So here is the syntax. Within a open and close curly braces, just pass the ID. So this ID is nothing but a URI template variable, and we need to bind the value of this URI template variable to the method argument. So in order to do that, we can use @path variable annotation over here. And next, let us pass the URI template variable, that is ID. Perfect. Next, we need to use one more annotation, that is @requestBody annotation. Well, this @requestBody annotation will basically extract the updated JSON from the request and it will convert that JSON into employee DTO Java object. Okay, perfect. Now we have built update employee REST API. Next, let us rerun our Spring Boot application and let us test this REST API using Postman client. So from here, I am going to stop and rerun the Spring Boot application. Well, notice here our Spring Boot application is up and running in an embedded Tomcat server on port 8080. Next, let us go to Postman client over here. And here, let me copy this URL and let me create the new request. And here, let us choose HTTP put method and let us enter the request URL localhost 800/API/employees. And then we need to pass the employee ID that we are going to update. So let us say we are going to update the employee with ID 1. Alright, next let us pass the updated information in the body. So click on body, raw, content type JSON, and here we need to pass the JSON. So here let me quickly create the JSON. Post name Ram and last name Jadhav, email ram@gmail.com. Next, go ahead and click on send button over here, and there we go. You can see the response. The post name is updated, last name is updated, and email is also updated. It means we have successfully built update employee REST API. Alright, great. In next lecture, we'll build delete employee REST API. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we are going to build delete employee REST API. So let's go to our project in IntelliJ over here. Well, first we'll change the service layer and then we'll change the controller layer, because the controller layer is depends on service layer. So let us go to employee service interface over here, and within this interface, let us define the method. So let us give void as a return type of the method, and let us give method name as delete employee, and let us pass employee ID as a parameter to this method. Next, let us go ahead and let us implement this delete employee method in our employee service IMPL class. So go to employee service IMPL class over here, just mouse over on this class, click on this implement methods and choose the method that you want to implement. Click on OK. Alright. Next, let us go ahead and let us implement this delete employee method. So here, first of all, we need to add the validation, like if employee with a given ID is not exist in database, then we have to throw the resource not found exception, isn't it? So if you go to update employee method over here, we have already written the logic. Okay, so let us copy this piece of code and go to delete employee method, and here just paste this piece of code. So here basically we are calling find by ID method, and this find by ID method returns optional. So again here we are calling or else through method of optional object, and here basically we are providing the lambda implementation of supplier functional interface. So basically if employee with a given ID is not exist in database, then this piece of code will basically throw the resource not found exception. Next, let us call employee repository. It has delete by ID method, and then pass employee ID as a parameter to this method. Okay, perfect. So this delete by ID method will basically delete the employee by ID. Alright, next let us create delete employee REST API that will internally call this method. So go to employee controller over here. Within employee controller, let us build delete employee REST API. So here let me write the comment first. Build delete employee REST API. So first we'll create a method, and then we'll convert that method into REST API by using Spring annotations. So here just type public and then response entity as a return type. So let us pass string as a type, and then let's give method name as delete employee. Alright, and let us pass employee ID as a parameter to this method. Perfect. Next, within our delete employee method, let us call employee service. It has delete employee method, and then pass employee ID. Next, let us have a return statement, return response entity dot okay, and let us pass the success message, that is employee deleted successfully, something like that. Perfect. Now we have created delete employee method. Let us make this method as a REST API by using Spring annotations. So here let us annotate this method with add delete mapping annotation. Well, we use add delete mapping annotation to map the incoming HTTP delete request to this method. Next, we need to pass the ID to this annotation. So here within a curly braces, just pass the ID. So this ID is nothing but a URI template variable, and we need to bind the value of this URI template variable to the method argument. So in order to do that, we can use add path variable annotation and then pass URI template variable name. Perfect. Now we have built delete employee REST API. Next, let us rerun our Spring Boot application and let us test this REST API using Postman client. So from here, I want to stop and rerun the Spring Boot application. Well, our Spring Boot application is up and running. Next, let's go to Postman client over here, and here let me copy this link and let me create a new request, and here let us choose HTTP delete method, and let us enter the request URL localhost 800/API/employees, and here we need to pass the employee ID that we are going to delete. For example, let us say we want to delete the employee with ID 1, then we have to pass the employee ID 1 in the request URL, and go ahead and click on send button over here, and look at here the response, employee deleted successfully, and the status code 200 OK. Alright, it means the delete employee REST API is working as expected. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this section of the lectures, we are going to build the REST APIs for simple banking application. Well, we are going to build add account REST API, get account REST API, deposit amount REST API, withdraw amount REST API, get all accounts REST API, and delete account REST API. So these are the simple REST APIs that we are going to build for banking application. Well, what are the tools and technologies that we are going to use to build this banking application? Well, we are going to use Java 17 plus, Spring Boot 2.3.1. This is the latest version of Spring Boot as of now, and we will use Spring Data API that internally uses Hibernate, and we will use MySQL database. We will use IntelliJ IDEA to develop this project. We are going to use Maven build tool, and we will use Postman client to test the REST APIs. Alright, great. In next lecture, we will kickstart our Spring Boot application for a banking application. Alright, great. I will see you in the next lecture. So just let us jump into the browser. So I am in a Chrome browser, and open the new tab over here and just type start.spring.io. This will bring up Spring Initializer, and here select the project Maven and choose the language Java, and let us keep the stable version of Spring Boot as of now, that is 3.2.1. so this is the latest and stable version of Spring Boot as of now. Next, go to the project metadata over here, and here let us give group as net.java guides, and let's give artifact as banking app. Next, project name is same as artifact, that is banking app. Next, description, let us give the description something like demo project for Spring Boot banking app. Next, let us give package name as net.javaguides.banking. Next, let us keep packaging as a jar, and let's keep Java version 17. Next, go to the dependency section over here, and here just search for web, and let us select this Spring Web Starter dependency. Well, we use this dependency to build the RESTful APIs, and this dependency internally provides Apache Tomcat server as a default embedded container. So let us select this dependency. Next, let us type Spring Data JPA. Well, we want to build the JPA repositories using Spring Data JPA. Well, this Spring Data JPA dependency internally provides latest version of Hibernate. Okay, so let us select Spring Data JPA over here. Next, type MySQL. So we want to use MySQL JDBC driver to connect our Spring Boot application with the MySQL database. Next, let us select the Lombok dependency. Well, we want to use Lombok dependency to reduce the boilerplate code such as getter setter methods, constructors, toString equals, and hash code methods. Okay, so let us select Lombok dependency over here. Alright, so as of now, these dependencies are enough for our Spring Boot application. Next, go ahead and click on generate button over here. So before that, you can also explore the Spring Boot application using explore option over here. So just click on explore, and here go to the pom.xml file, and you can see the Spring Boot version, Java version, and the dependencies as well. Okay, perfect. Next, click on close button, and go ahead and click on this generate button to generate the Spring Boot application as a zip file. Okay, next go ahead and open this zip file in a folder. Perfect. Next, let us unzip this zip file. Alright, next let us open the IntelliJ IDEA. So here I have opened IntelliJ IDEA. Next, click on open option over here to open the existing project. In my case, the project is downloaded in a downloads folder. So let me go into the downloads folder over here, and next let me select the project. Let me click on open. Now we have successfully imported the Spring Boot application in IntelliJ IDEA. Next, let us go ahead and let us start developing this Spring Boot application. Next step is we will configure the MySQL database in our Spring Boot application so that our Spring Boot application can able to connect to the MySQL database. So go to the src folder and go to main folder, go to resources, go to application.properties file. So here inside application.properties file, we want to configure the MySQL database details. Okay, so before configuring MySQL database details in the application.properties file, let us first create the database in a MySQL server. So in our case, we are going to use MySQL Workbench to interact with the MySQL server. So here, let me quickly create the new database. So here, let us write the SQL statement, create database followed by the database name. So let us give database name as banking app. Next, let us select this, click on execute, and next refresh schemas. And here you can see banking app database is successfully created. Next, we can make this schema or database as a default so that we can only focus on this database. Next, let's go back to IntelliJ IDEA over here and go to application.properties file, and here let us configure the MySQL database properties. So just type spring.datasource.url equal to JDBC and then MySQL and then localhost and then port 3306 and then followed by the database name banking_app. So this is the JDBC URL that our Spring Boot application will use to connect with the MySQL database. And here we are using localhost because our MySQL server is running in a local machine. That's why the host name is localhost. And this is the default port for a MySQL server. And this is the database name. Next, let us configure the MySQL database username and password. So here spring.dataSource.username. In my case, the username is root. Next, let us configure the password. Spring.dataSource.password. Well, in my case, this is the password, but make sure that whatever the database username and password that you have given while installing the MySQL database, that you have to provide over here. Next, let us tell Hibernate to automatically create the tables using JP entities. For that, let's configure the property spring.jp.hibernate.dtl-auto equal to update. Alright, so this property basically ensures that the Hibernate should create the database tables automatically based on the JP entities that we will create in the Spring Boot application. Next, we no need to add Hibernate delete for a MySQL database because Spring Boot 3 internally uses Hibernate 6, and Hibernate 6 will automatically configure the Hibernate delete for a database based on the JDBC driver dependency that we add in the Spring Boot application. In our case, we have added MySQL JDBC driver, so Hibernate 6 will automatically configure the Hibernate delete for a MySQL database. Okay, perfect. Next, let us run the Spring Boot application so that we can make sure that our Spring Boot application can able to connect to this banking app database. So go to our main entry point class over here, and from here let us run the Spring Boot application, and here click on enable button to enable the Lombok annotations. And notice here there are no errors in a console logs. It means our Spring Boot application is successfully connected with the MySQL database. Next step is we will create a JPA entity. So before that, let's quickly create the packaging structure for our Spring Boot application. So right click on the base package, new, and then choose package. Let's give name as entity. Next, let's create one more package. Right click, new, and then choose package. Let's give package name as controller. Next, right click, new, and then choose package. Let's give package name as service. Next, let's create one more package. Let's call it as repository. Perfect. Next, go to entity package, right click on it, new, and then choose Java class. Let's give class name as account. Next, let us define the fields for this account class. Private long ID, and then private string. Let's give name as account holder name, and then private double balance. Well, to keep it simple, let us have these three fields for our account class. Next, let us make this class as a JP entity by using JP annotations. So let us annotate this class with add entity annotation to make this class as a JP entity. Next, let us configure the table details by using add table annotation. So here let's use name attribute to give a name to the table. Let us say accounts. Perfect. Next, let us use Lombok annotations to automatically create a getter setter methods for this account class. So here let us use add getter Lombok annotation, and next let us use add setter Lombok annotation. Next, let us also use the constructor related annotations. For example, no argument constructor and all argument constructor annotation. Next, let us use few more JP annotations over here. So go to the ID field and let us annotate this ID field with add ID annotation to make this ID field as a primary key in a database. Next, let us use add generated value annotation to configure primary key generation strategy. So this annotation has a strategy attribute, and let us give the generation type as a identity. So this will basically automatically increment the primary key. Next, here let us use add column annotation to configure the column name for this field. So here let us use name attribute and let's give column name as account underscore holder underscore name. Okay, perfect. Now we have created account JP entity. Next, let us run this Spring Boot application and let us see whether the Hibernate will automatically create a table for this account JP entity or not. Okay, so go to main entity point class over here. From here, let us run the Spring Boot application. And notice here there are no errors in the console. Let's go to database and go to banking app database, refresh the schemas, go to tables, and there we go. Accounts table is created and the columns like ID, account holder name and balance. It means the table is successfully created and the columns are also looks good. Okay, so let's go back to IntelliJ idea. Next step is let us create Spring Data JPA repository for this account entity. Okay, so go to a repository package, right click on it, new, and then choose Java class, choose interface, and here let us give the interface name as account repository. Perfect. Next, let us extend this interface from JPA repository interface. And notice here JPA repository interface is a generic, so we have to pass two parameters. First is the entity name, in our case account. Second is the type of the primary key, in our case long. Okay, so if you go to account JPA entity, so we have given the long type to this ID field, right? So this long we are passing as a second parameter to this JPA repository interface. Okay, great. Well, once we create account repository interface that extends JPA repository interface, then this account repository will get a CRUD database methods to perform CRUD database operations on this account JPA entity. Alright, perfect. Next step is create add account REST API. So before creating the REST API, let us first create the service layer. Well, the controller layer is depends on service layer. So let us first create add account method in a service layer, and then we'll create the REST API, and that REST API will internally call the service method. So here go to service package, right click on it, new, and then choose Java class. And let us select interface and let us give interface name as account service. Okay, next let us define the method over here. So let us say account and then create account, and let us pass account. Well, we can also use a DTO to transfer the data between client and server. Okay, so what we will do, we will use the DTO. So let's create a new package for it, and let's give package name as DTO, and here let us create a class and let us give class name as account DTO, and here let us type the field private long ID and then private string account holder name and then private string, let us go double, and then balance. Alright, and here let us use at data lambda connotation to automatically generate constructors, getter, setter methods. Next, let's go back to account service interface, and here instead of account JP entity, let us use account DTO. So here also let us pass account DTO. Okay, perfect. And let's view the name as account DTO, and let's remove this unused import. Okay, perfect. Next, go to service package and let's create one new package, and let's call it as IMPL. IMPL stands for implementation. So all the implementation classes we keep under this IMPL package. So right click on this package, new, and then choose Java class. Let's give class name as account service IMPL. So this is the naming convention. Next, this class implements account service interface and implement its methods. So here just mouse on this class, click on this implement methods, select the method that you want to implement, click on OK. Perfect. Next, let us annotate this class with add service annotation to automatically create a Spring Bean for this class. Next, let us inject the dependency. So here, let us first declare the field private account repository. Next, let us use a constructor based dependency injection to inject this account repository dependency. So here, right click and then generate and then constructor and select the dependency, click on OK. Alright, next here we can annotate this constructor with @attribute annotation to automatically inject the dependency, but Spring 4.3 onwards we can ignore this @attribute annotation, because whenever Spring will find the single constructor in a Spring Bean, then Spring will automatically inject the dependency. Okay, perfect. Next, go to create account method over here, and within this method we need to convert account DTO into account JP entity, and then we'll save that account JP entity into a database. So this is the conversion logic, right? So let us create one mapper class and let us write the common logic, like we can convert a DTO into JP entity and JP entity into DTO. So here go to DTO package, or else let's create one more package and let's call it as mapper. Next, within a mapper package, let's create a new class. Let's call it as account mapper. So within account mapper class, let's create static method public static, and let us give the return type account, and let us give method name as map to account, and let us pass account DTO as a parameter. Perfect. Next, let us convert this account DTO into account. So here let us create the object account, and then account equal to new account. Next, let us pass the details to the constructor account DTO.getID, and then account DTO.get account holder name, and then account DTO.get balance, and then finally I return the account object. Now we have converted account DTO into account JP entity. Similarly, let us write one more static method to convert account JP entity into account DTO. So here just type public and then static and then return type as account DTO. Let's give method name as map to account DTO, and let us pass account JP entity. Perfect. Next, let us create account DTO object over here. Alright, and let us pass values to the constructor like account dot get ID, and then account dot get account holder name, and then account dot get balance, and then finally return this account DTO. Well, let us see what is the compilation error over here. It says the parameterized constructor is not available in the account DTO. So go to account DTO over here. So this add data annotation don't provide the constructor. So here let us use add argument constructor annotation. Okay, let's go back to mapper class, and there we go. Alright, now we have created a mapper class to map DTO into entity and vice versa. Next, let us use this account mapper class in the service classes. So go to account service IMPL class over here and go to create account method, and here let's create an object of account and then account, and then let us call account mapper over here, account mapper, and then it has map to account method and then pass account DTO. Next, let us call account repository over here, and then it has save method. So let us call save method to save the account JP entity, and then pass account JP entity object to this save method. So this save method basically return the saved entity. So here let us introduce a local variable of type account, and let's give variable name as saved account. Okay, perfect. And if you look at the create account method return type account DTO. So let us convert saved account into account DTO. So here let us remove this null and then call account mapper and then map to account DTO and then pass saved account. Okay, perfect. Now we have created create account method. It will call the account repository to save the account into the database. Next, let us create the REST API and then that REST API will internally call this method. So go to controller package over here, right click on it, new, and then choose Java class. Let us give class name as account controller. Let us annotate this account controller class with @REST-controller annotation. So this @REST-controller annotation will make this class as a Spring MVC REST controller class. Next, let us annotate this class with @request mapping annotation. And let us pass the base URL over here. Let us say /API/accounts. Okay, so this is basically a base URL for all the REST APIs that we are going to define within this account controller class. Okay, great. Next, let us inject the dependency. For that, let us first define the field, that is private account service. Next, let us use a constructor based dependency injection to inject this account service dependency. So here right click, generate, and then constructor, and then click on OK. Now we have injected account service using constructor based dependency injection, and here again we don't have to use @word annotation because this class has only one constructor, so Spring will automatically inject the dependency. Next, here let's create a add account REST API. Well, creating a REST API using Spring Boot is very simple. First we need to create a method and then we'll make that method as a REST API by using Spring annotation. Okay, alright, so just type public and then let us use response entity as a return type, and this is generic, so we can pass account DTO as a type. Let's give method name as add account and then pass account DTO as a parameter to this method. Alright, perfect. Next, let us have a return statement over here. Return new response entity and then call account service dot create account and then pass account DTO. Next, let us pass the HTTP status, that is created. HTTP status created. Perfect. Now we have created add account method. It will call account service dot create account method, and this create account method basically return the saved account. So this is the first argument. Second argument is HTTP status. Okay, perfect. Next, let us make this method as a REST API by using Spring annotation. So in this case, this method have to handle the HTTP post request. For that, let us use @post mapping annotation. Next, here let us use one more annotation, that is @request body annotation. So this @request body annotation will map the request body to this Java object. So request body basically contains JSON, so this @request body will automatically convert that JSON into this Java object. Okay, perfect. Next, let us go ahead and let us run our Spring Boot application and let us test this add account REST API. So from here I am going to stop the running application first and I am going to run the application again. And notice here our Spring Boot application is up and running in a embedded Tomcat server on port 8080. Next, let us open the Postman REST client, and here let's create one new request, and here let us choose HTTP post method and just type the request URL http localhost 8080/API/accounts. Okay, so if you go to project again and if you go to account controller, the URL is /API/accounts. So this is the URL we are using over here, /API/accounts. Okay, next go to body and then select raw, select content type as a JSON and here we need to pass the JSON in the request body. So let us quickly create the JSON object. So if you go to project again, and if you go to account DTO, so this account DTO has field account holder name and balance. So these fields we have to use in a JSON. So let me copy this field name and let me paste it over here, and then let's give holder name, in my case Ramesh. Next, balance, let us say 10,000. Okay, next go ahead and click on send button, and there we go, we got the response from the server. And if you look at the ID here, 1, so this ID we are getting from the database. And look at the status, 201 created. Let us verify in the database. So go to MySQL Workbench, go to accounts table, select rows, and you can see the account is successfully stored in a accounts table. Okay, perfect. Now we have successfully built add account REST API. Next, let us build get account REST API. So let's go back to our IntelliJ idea. So here let's first change the service layer. So go to account service interface and let us define the method. So here let's give method name as account DTO. Let's give method name as get account by ID, and then pass ID as a parameter. Perfect. Now we have defined get account by ID method in a account service interface. Next, let us implement this method in a account service IMPL class. So go to account service IMPL class over here, just mouse over on this class, click on implement methods, select the method that you want to implement, click on OK. Next, let us implement this get account by ID method over here. So here just call account repository, it has find by ID method, and notice here find by ID method returns optional of type account. Okay, so just call find by ID and then pass ID over here, and then call or else throw method over here. Well, let us say the account with a given ID is not existing in database, then we have to throw the exception. For that we can use or else throw method over here. So just call this or else throw method, and then here let us pass the lambda expression implementation. Well, this or else method takes supplier functional interface, and we have to provide the lambda expression implementation for this supplier functional interface. So here is the lambda expression to create a new exception and throw that exception. New, let us throw the runtime exception over here. You can create your own custom exception and you can throw that exception from here. So let us say account does not exist. Okay, perfect. Next, here let us take the return return value from this method. Let us say account. Next, this get account by ID method returns account DTO. So let us convert this account JP entity object into account DTO. For that, let us call account mapper, and then it has map to account DTO, and then pass account. Perfect. And here let me align this properly. Perfect. Now we have created get account by ID method in a account service IMPL class. Next, let us create get account REST API that will internally call this method. So go to controller layer and go to account controller class, and here let's create get account REST API. So here let me first write the comment get account REST API. Let us type the method public and then response entity, and then pass account DTO as a type. Let's give method name as account get account by ID, and then pass ID as a parameter to this method. Next, let's call account DTO and then call account service dot get account by ID and then pass ID. Perfect. Next, let us have a return statement, return and then response entity dot OK, and then pass account DTO in a body. Perfect. Now we have created a get account by ID method. So let's refactor this. Now we have created get account by ID method. It returns the account object, and look at the OK method. So this OK method internally returns the HTTP status 200 OK. Alright, perfect. Next, let us make this method as a REST API by using Spring annotations. So this method have to handle HTTP GET request. For that, let us use add get mapping annotation. Okay. So this add get mapping annotation will map the incoming HTTP GET request to this particular method. Next, let us pass ID to this annotation. Within a double quote slash within a curly braces, just pass ID. So this ID is nothing but a template, variable. Next, we need to bind the value from this template path variable to this method argument. For that, we can use add path variable annotation over here. Alright, perfect. Now we have built get account REST API. Next, let us rerun our Spring Boot application and let us test this get account REST API. So from here, let us stop and rerun the Spring Boot application. Well, notice here our Spring Boot application is up and running in an embedded Tomcat server on port 8080. Next, let's head over to the Postman client over here, and here let's create a new request. Let us enter the URL http :localhost 8080/API/accounts, and then pass account ID 1. Next, click on send button, and there we go. We got the response from the server. And look at here the ID 1, account holder name Ramesh, balance 10,000, and the HTTP status 200 OK. Now we have developed a get account REST API. Next, let us build deposit REST API. Well, basically we are going to develop the REST API that will deposit amount into a account holder name. For example, here the account holder is Ramesh. He has a balance 10,000. Next, we are going to deposit some amount into this, Ramesh account holder. Alright, so basically we are going to add some amount to the existing balance. Okay, it's pretty simple. So let us go to IntelliJ over here, and let us first develop the service layer. So go to account service interface, and here let's give account DTO as a return type. Let's give method name as deposit, and let's pass first parameter as ID. Next, let us pass second parameter as a amount that we want to deposit into account. Now we have defined deposit method in account service interface. Next, let us provide the implementation for this deposit method in a account service sample class. So let us jump into account service sample class. Mouse over on this class, click on implement methods over here, and then click on OK. Next, let us implement this deposit method. Well, within a deposit method, first we'll check whether the account with a given ID exists in a database or not. If the account with a given ID is not exist in database, then we'll throw the runtime exception, right? So here we have already written a piece of code. So let me copy this piece of code and let me paste in a deposit method. Now we got the account for this particular account ID. Next, let us call its get balance method, and then add this amount to existing balance. Okay. Next, here let us introduce a local variable double, and let's call it as total equal to. Perfect. Next, let us call account, and then let's call it set balance method, and then pass total. Okay, perfect. Next, we need to save this object into a database. For that, let us call account repository, and then call save method, and then pass account object. Perfect. Next, this save method returns saved account object. So here let us introduce a local variable account, and then saved account. Next, this deposit method returns account DTO. So let us convert this account JP entity into account DTO. So here let us remove this null, and then call account mapper. It has map to account DTO, and then pass saved account. Okay, perfect. Now we have implemented deposit method. It will deposit amount into a account. And the logic is pretty simple. We'll get the existing balance from the account and we'll add the amount to the balance, and then we'll get the total amount, and then we'll add that total amount as a balance to the account, and then we'll save that account into a database. Okay, it's pretty simple. Next, let us build the deposit REST API that will internally call this method. So go to account controller and here deposit REST API. Alright, so here let's type public, let's give return type as a response entity, and here let's give the type as account DTO, and let's give method name as deposit, and then let us pass two parameters to this method, long id, and then second parameter as map. It takes key as a string, value as type double. So basically we'll pass amount in a request body. For that we'll use a map. Okay, next let us call it as request. Perfect. Next, within this deposit method, let us call account service. It has deposit method, and then let's pass id as a first parameter. Second parameter we need to pass the amount, so we can get that amount from the request object. So here request dot get, and then we can pass key as a amount. Okay, next let us introduce a local variable amount account DTO. Okay, next let us have a return statement, return response entity dot okay, and then pass account DTO in a body. Now we have created a deposit method, and then internally we'll call account service dot deposit method, and then we'll pass id and then amount. So we can extract this as a separate variable as well. So here what we'll do, we'll store in a local variable, let us say double, and then amount equal to request dot get, and then pass this amount over here. Okay, so this will basically improve the readability. Next, let us annotate this deposit method with @put mapping annotation. Well, we use @put mapping annotation to map incoming HTTP put request to this method. Next, within a double quote slash, and then pass id, next slash deposit. So this is the URL for this REST API. Next, let us store the value of this id into a method argument using @path variable annotation. So here let us use @path variable annotation to bind value of this template URI variable to this method argument. Next, here let us use one more annotation, that is @request body annotation. Well, this @request body annotation will map the request JSON body into this map Java object. Okay, perfect. Now we have developed the deposit REST API. Next, let us go ahead and let us rerun our Spring Boot application, and let us test this deposit REST API. So here let me stop and rerun the Spring Boot application. Alright, our Spring Boot application is up and running. Next, let us head over to the Postman client over here, and here let's create a new request, and here let us choose HTTP put method, and here let us enter the request URL. So let me copy this and let me paste it over here. Next, let's go to body and then choose raw, and then choose content type JSON, and here let us pass the JSON and the key as amount and the value. Let us say we want to deposit 5,000. Okay, that's it. Next, click on send button. So this says method not allowed. Well, here we need to give the correct URL. So let's go to IntelliJ IDEA, and let's see the URL that we have given to the REST API. We have given the URL id/deposit. So we need to append this deposit in the URL as well. So here's /1/deposit, and then click on send button, and there we go. In a response, you can see the JSON account 1, account holder name Ramesh, and the balance is 15,000. Earlier it was 10,000. Now you can see the balance 15,000. Okay, it means we have successfully deposited 5,000 into account Ramesh. Next, let us say we want to deposit 10,000. Next, click on send button and you can see the response. The total balance 25,000. It means the deposit REST API is working as expected. Next, you can see the same change in the database table as well. So go to accounts table, right click, select rows, and you can see the balance 25,000. Okay, it means we have successfully built deposit REST API. Okay, great. Next, let us build withdraw REST API. So let us go to IntelliJ IDEA and let's create the withdraw REST API. So let us first change the service layer and then we'll change the controller layer. So go to account service interface and here let's define the method. Let's give return type as account DTO. Let's give method name as withdraw and let's pass parameter as long ID. Let's also pass the second parameter, that is amount. Perfect. Now we have defined withdraw method in a account service interface. Next, let us provide the implementation for this method in a account service sample class. So let us jump into account service sample class. Just mouse over on this class, click on implement methods, select the method that you want to implement, click on OK. Perfect. Next, let us implement this withdraw method over here. So here, first we'll check whether the account with a given ID is exist in a database or not. If the account with a given ID is not exist in database, then we'll throw the exceptions like account does not exist. Okay, so that piece of code we have already written in a existing methods. So we can copy that piece of code from here. So go to deposit method and copy this piece of code. Okay, and again go to withdraw method and here simply paste it. Okay, perfect. Next, let us add one more condition, like if the withdraw amount is greater than the balance, then we'll throw the exception like insufficient amount. Okay, so here let's add the if condition and then account dot get balance. So if the account balance is less than the withdraw amount, then we'll throw the runtime exception. So here throw new runtime exception and let us pass the message insufficient amount. Perfect. Next, here let us write the logic double total equal to, so here just call account dot get balance minus amount. So in this case we are withdrawing the amount from the balance, that's why we are using a subtraction. Okay, next let's call account dot set balance and then pass total. Okay, perfect. Next, let us call account repository and then call save method and then pass this account object. Next, this save method returns the account saved account object. So let us introduce a local variable of type account. Let's call it as saved account. Perfect. Next, if you can look at the withdraw method over here, it returns the account DTO. So let us convert account entity into account DTO. So here let us remove this null and let's call account mapper and then it has map to account DTO and then pass saved account. Okay, perfect. Now we have implemented withdraw method. Internally it will call account repository dot find by ID method. Let us say if the account with a given ID is not exist in database, then we will throw the runtime exception. Next, we have added one more condition, like if the withdraw amount is greater than the balance, then we'll throw the runtime exception like insufficient amount. Next, let us say the balance is greater than the withdraw amount, then we'll write the logic like we'll withdraw some amount from the existing account balance and then we'll add that total to the account and then we'll save that account into a database and then we'll return the updated information. Okay, the logic is pretty simple. Next, let us build the withdraw REST API that will internally call this method. So go to account controller. So here let me first write the comment withdraw REST API. So just type public and then response entity and then pass account DTO. Let's give method name as withdraw and then pass two parameters. First parameter as ID, second parameter as a map. The key type is string, the value type is double, and let's call it as request. Perfect. Next, let us get the amount from the request. So here double and then amount equal to request dot get and then pass amount. Alright, next account DTO equal to account service dot withdraw and then pass ID and then amount. Next, let us have a return statement, return response entity dot OK and then pass account DTO in a body. Perfect. Now we have created withdraw method. It will internally call account service dot withdraw method and it will pass account ID and the withdraw amount. Okay, next let us make this method as a REST API by using Spring annotations. So here let us annotate this method with add put mapping annotation. Well, this put mapping annotation will map incoming HTTP put request to this method. And then let us pass the ID and then withdraw. Perfect. Next, let us bind the value of this ID to this method argument by using at path variable annotation. Next, let us use one more annotation, that is at request body annotation. Now we have built withdraw REST API. Next, let us rerun our Spring Boot application and let us test this REST API. So from here, let us stop and run the Spring Boot application. Alright, our Spring Boot application is up and running. Let's go to Postman client over here and here let's create a new request. So let me copy the request URL from the existing REST API request. So here let us select HTTP put method and then pass request URL localhost 8080/API/accounts/ the account ID and then withdraw. Alright, so here we are going to basically withdraw some amount from the account with ID 1. Next, let us go to body, select raw, choose content type JSON, and here let us pass the withdraw amount. Let us say I want to withdraw 5,000. Next, click on send button and there we go. In a response you can see the account holder name and the balance. Earlier the balance was 25,000. Now you can see the balance 20,000 because we have withdrawn the amount 5,000. Okay, next let us say I want to withdraw 5 more thousand. Then what I can do is I can click on send button and you can see the response. The balance is 15,000. Next let us say I want to withdraw 10,000. Then the balance should be 5,000, right? So let's click on send button and you can see the balance 5,000. It means the withdraw REST API is working as expected. Next, let us build get all accounts REST API. Well, first we'll change the service layer and then we'll change the controller layer because controller layer depends on service layer. So let us head over to account service interface over here, and within this interface let us declare a method. So let's give the method return type as list. List is a generic, so let us pass account DTO as a type. Let's give method name as get all accounts. Perfect. Next, let us go and let's implement this method in a account service IMPL class. So let us jump into account service IMPL class over here. Just mouse over on this class and here you will get a link to implement the methods. Click on this implement methods, select the method that you want to implement, and click on OK. Next, let us write the logic to implement get all accounts method over here. So within a get all accounts method, let us call account repository. It has find all method, and notice here find all method returns a list of account. So just call this find all method over here. Next, let us get the result of this find all method in a list. So list and then account. Let's call it as accounts. Okay, now we got a list of accounts. Next, let us convert this list of account into list of account DTO. So here let us call accounts. So accounts is a list and list has a stream method. So here just call stream method, and then stream has a map method. So let us use map method to map entity into DTO. And look at here, map method takes function as a functional interface. We need to provide the lambda expression implementation of this function functional interface. So let us call this map method over here, and let us pass the lambda expression implementation. Well, here let us pass account entity object as a parameter to the lambda expression, and then this is the lambda symbol, and then call account mapper. It has map to account DTO method, right? And then pass account entity object. Next, let us call collect collectors dot toList method. Okay, perfect. Well, here we are using account mapper dot map to account DTO method to map account entity object into account DTO. And finally, we are returning the list from the stream, and this list basically contains the list of account DTO. Okay, so here let us have a return statement and remove this return null. Okay, now we have implemented get all accounts method. It will return the list of account DTOs. Next, let us create get all accounts REST API that will internally call this method. So let us head over to account controller over here, and here let me write the comment get all accounts REST API. Perfect. So here let us first create the method, and then we will make that method into REST API. So just type public and then response entity. Response entity is a generic. Let us pass type as a list, and again list is a generic. So let us pass account DTO as a type. Let's do method name as get all accounts. Okay. Next, within this method, let us call account service and then call get all accounts method. So this get all accounts method return list of account DTO. So here let us have list and then account DTO. Let's call it as accounts. Perfect. Next, let us have return statement and then response entity. It has OK method and then pass accounts in a body. Perfect. Now we have created a method called get all accounts. It returns a list of account DTOs. Next, let us make this method as a REST API by using Spring annotations. So here let us annotate this method with add get mapping annotation. Okay, that's it. Next, let us go and let us rerun our Spring Boot application and let us test this get all accounts REST API. So from here, I am going to stop and rerun the Spring Boot application. Well, notice here our Spring Boot application is up and running in embedded Tomcat server on port 8080. Next, let us head over to the Postman client over here and let's create a new request and let us choose HTTP get method over here and let us enter the request URL. Well, let us copy from the previous REST API and just paste it over here, and here let us remove these parameters and just keep localhost 8080/API/accounts. Next, go ahead and click on send button, and there we go. In a response, you can see a list of accounts. So as of now, there is only one account. Now what we'll do, we'll add a few more accounts. Okay, so go to the add account REST API over here, and here go to the body and just change the account holder name from Ramesh to John, and then balance let us have 20,000. Click on send button. Now the John account is created. Next, let's create one more account. Let us say Sanjay, and then let's say balance 30,000. Click on send button, and there we go, Sanjay account is created. Next let's go to get all accounts REST API, and next send the request, and there we go. In a response you can see a list of accounts, and there are total 3 accounts in the list. Alright, it means the get all accounts REST API is working as expected. Alright, great. Next let us go ahead and let us build delete account REST API. Well, first we'll change the service layer and then we'll change the controller layer. So go to account service interface over here, and here let's define the method. So let's give return type of the method as a void, and let's give a method name as delete account, and then pass account ID as a parameter. Now we have defined delete account method in account service interface. Next let us implement this method in account service IMPL class. So let us jump into account service IMPL class over here, and just mouse over on this class, click on implement methods, select the method, click on OK. Alright, next let us implement this delete account method over here. Well, first we'll add the condition like if the account is not exist for a given ID, then we'll throw the runtime exception. Okay, so that logic we have already written in a withdraw method and deposit method and get account by ID method, right? So let us copy this piece of code from the get account by ID method, and then let's go back to delete account method over here, and within this method let us paste this logic. So here basically we are adding the condition like if the account with a given ID does not exist in database, then we will simply throw the runtime exception like this. Okay, great. If the account with a given ID exists in database, then we will delete that account. So for that, let's call the account repository. It has a delete by ID method, and then pass account ID. All right, perfect. So this delete by ID method returns a void, so we no need to return anything. Now we have implemented delete account method. It will delete an account by given ID. Next let us build the delete account REST API that will internally call this delete account method. So let's go to account controller over here, and here let's write the comment first, delete account REST API. Just type the method public and then response entity. Let us pass string as a type. Let's give method name as delete account, and then pass account ID. Perfect. Next, within delete account method, let us call account service. It has delete account method, and then pass account ID. So this will basically delete the account by ID. Next, let us have a return statement, return response entity dot OK, and then pass the success message here. Let us say account is deleted successfully, something like that. Perfect. Now we have created delete account method. It will delete the account by using account service dot delete account method and return the success message. Next, let us make this method as a REST API by using Spring annotations. So here let us annotate this method with @delete mapping annotation. When we use @delete mapping annotation to map incoming HTTP delete request to this particular method. Next, let us pass the URI template variable over here. So here braces within a double quote slash within a curly braces ID. So this ID is nothing but a UI template variable, and this ID basically contains the account ID. So we need to bind the value of this ID into the method argument. For that, let us use @path variable annotation. Okay, perfect. Now we have implemented delete account REST API. Next, let us rerun our Spring Boot application and let us test this delete account REST API. So from here, I'm going to stop and rerun the Spring Boot application. Well, notice here our Spring Boot application is up and running. Next, let us head over to the Postman client, and here let's create a new request. Let us choose HTTP delete method over here, and here let us enter the request URL. So let me copy this and let me paste it over here, localhost 8080/API/accounts. So let us say we want to delete the account with ID 1. So just pass ID 1 in the URL. Next, click on the send button over here, And there we go. You can see the response. Account is deleted successfully with HTTP status 200. Okay. Next, let us verify in the database. So let's go to MySQL workbench over here and go to accounts table, select rows, and notice here the account with ID 1 is deleted from the accounts table. Next, let us delete the account with ID 2 as well. So let's go to Postman client, and here let us pass the account ID 2 in the URL and click on send button, and there we go, we got the success message. Next, let's verify in the database. So here let us refresh the table, that is select rows from the table, and there we go, the account with ID 2 is successfully deleted. It means the delete account REST API is working as expected. Alright, great. Hi everyone, welcome back. In this lecture, let us see how to use a Java record class as a DTO class in our banking application. Well, if you look at the banking application code here, we have used a normal class as a DTO class to transfer the data between client and server. Now, we are using Java 17 plus, so we can utilize the latest feature of Java, right? So record class is a special type of class which is introduced in Java 16. So we can use record class to transfer the data between client and server. And the record class basically is a special kind of class that helps you to encapsulate a related data without the need for boilerplate code. It means once we create a record class, then Java compiler will automatically generate a getter methods, setter methods, constructors, equals, hash code, and toString methods. So in normal Java class, we have to manually create all these boilerplate code, right? But this Java record class tells Java compiler to automatically generate all this boilerplate code. Using record class as a DTO in a Spring Boot application is a modern and efficient approach to encapsulating data transfer between application layers. So basically, record class holds the immutable data, and it is a good candidate as a DTO to transfer the data between different layers. Next, records are good fit for DTOs because they are concise, immutable, and automatically provide the implementations of getter methods, constructors, equals, hash code, and toString methods, which are essential for DTOs. So let us go ahead and let us see how to use a record class as a DTO in our banking application. So let's go to our project in IntelliJ IDEA and go to account DTO class over here, and here let us go ahead and comment out this code. So here just type public and then record keyword, and let us give record name as account DTO, and next define the fields long ID and then string account holder name and then double balance. Perfect. So basically these fields are implicitly final. So once we create this account DTO object, we cannot modify it because records are immutable. Alright, perfect. Next, let us go to account mapper class over here, and here we have to change these getter methods because record basically provides a getter method name as a field name. For example, here let us remove this get ID method and then call ID. Next, let us remove this and then call account holder name. Next, let us remove this get balance and then call balance. That's it. Now what we have done, we have created a record account DTO and then we have changed in a account mapper. Okay, that's it. Next, let us rerun the Spring Boot application and let us test couple of REST APIs. So from here, I'm going to start the Spring Boot application. So notice here our Spring Boot application is up and running. Next, let's go to the Postman client and let us test couple of REST APIs. So here first let us test create account REST API. So here I'm going to create a new account with a holder name Ramesh. So before that, let us go to the database table over here and let us select the rows from the accounts table. So there is only one account holder, that is Sanjay. Next, let us insert one more account. So here let us give account holder name as Ramesh and the balance 10,000. Click on send button and there we go. The record is successfully created. Let us verify in the database table and you can see here Ramesh record is inserted. Okay, it means the create account REST API is working as expected. Next, let us test get account by ID REST API. So here let us select HTTP get method and here let us pass account ID 6 and then click on send and there we go. we got the response of the REST API. Next, let us test withdraw REST API. Okay, so here let us pass the account ID 6 and then click on send button. So basically look at here the amount 10,000 we want to withdraw, and look at here the response. And if you go to database table, the Ramesh user has a balance 10,000 and we have just withdrawn that 10,000 and balance remains 0. Okay, it means withdraw amount REST API is working as expected. Next, let us test the deposit REST API as well. Let us deposit 20,000 to the Ramesh account. So click on send button and there we go, the balance 20,000. And let us verify the database table and look at here, Ramesh has a balance 20,000. Next, let us test get all accounts REST API. So here let us remove the ID from the URL, click on send button and there we go, there are 2 accounts in the database table and same we can see in the response of the REST API. Next, let us test the delete account REST API. So here let us pass account ID 3 and click on send button and there we go, account is deleted successfully. It means we have successfully used record class as a DTO class to transfer the data between client and server. Alright, great.